So, first of all, I'd like to make one thing clear. I'm not talking about inter-app communication, that should not be confused about. Is the communication of components inside an application. Uh, so, first I'll explain what those components are, what I'm trying to do. These are the nodes of the communication. They are mostly Android specific components I'm going to focus on. These are activities, services, fragments, etc. And there could be other Java classes, Java specific classes involved. There are models, network classes, and thread, but all inside an application. And this is a sample situation which I'm going to focus throughout the talk. This is basically a blueprint of a music application, music app in Android or iOS, and this is very much similar to the Google Play, the Play Music app of Google, that Android provides. It has a player activity, and the player activity is going to have a list. The list could be of anything: songs, albums, artists, anything. And there is a media player, which all with all the commands, all the possible commands. And in the system, we are going to have a service that is actually going to play the music in the background, even if the UI is not visible. The service is going to play the music. In this situation, I have listed down few possible communication cases that we are going to have. The list controller. I'll keep switching between these two slides now to explain the communication cases. So whenever a person taps on a song, whenever a person taps on a song, it needs to communicate the track ID to music player so that it can actually tell music player service to play the track. So then this is going to be this list fragment is going to communicate the track ID to music media player. Media player is going to communicate it further to music player service. Okay. Now, the case of communication they are going to have is media player telling the music service and the list fragments about change of track. The user can change track next and previous tracks, or stop or pause anything. So it needs to be communicated to service and the list fragment. They are going to have related changes to user interacting in the media player. And then music player service can tell media player on certain events like track completion, time update, etc. So, and that communication is supposed to be further communicated to the list fragments to do the UI changes, required UI changes in the list. So, related to this, I'm going to cover these points. First, I'll before going deep into the communication patterns, I'm going to talk about. I will tell a little about the few background concepts that my communication patterns are going to depend on. The dependency and forms of coupling. Then I'm going to talk about interface. These are basically, rest of the points are basically the techniques of decoupling the code, decoupling various parts of the code. So first is interface, then I'm going to talk about message bus and the different implementations of message bus. These are implicit intent message bus and event bus, that revolves around an event. Event is just a normal Java class, and I have an idea of a better event bus I'll like to discuss today. And then in the end, I'm going to have few recommendations about how different patterns should be used. So, what is dependency? It's a normal Java concept. Like when a class uses another class, like class A uses class A, class B, or interface B. A is depending on B. That is, A cannot function without existence of B. So A is a dependent, B is a dependency. Dependency has various negative points. Like first of all, reusability. When you have to plug and play into some other application, you need to have B along with it. So that also obviously hampers the development speed, the code quality, and code readability. Degree of dependency. Degree of dependency, first of all, is not a binary thing. It is not the shape. It is not like black and white. It's going to have shades of gray. It's you can always have dependency. Dependence, you are not never going to get rid of dependency. There's always going to be some degree of dependency in your code. Even if it is depending on a single property, it is going to be there. So, one question while determining how much of dependency we have is what I just talked about. In order to use a class, how much other code needs to be used along with it. Like if I have to say I've got a class called A and I need to use it in some other application, I would have to check how many other classes or interfaces or other components I need to carry along with it to the other application in order to use it. And we should try to reduce that. Tight coupling. So actually, dependency, the degree of dependency oscillates between tight and loose coupling. Tight coupling is the extreme where dependency increases, and the loose coupling is the extreme where dependency decreases. Tight coupling mostly happens if you keep references of classes and other classes and directly call methods of them. So that means the dependency class or interface is going to have coupling methods. This makes the code inflexible, error prone, modularization is not possible, debugging can be painful. It is especially troublesome when in a multiple developers involved. When you have multiple developers involved in a project and the code is tightly coupled, there's a good chance that the other developer is going to mess the code up of the first developer. If you have written a tightly coupled code, there's a good chance that someone else, the other developer is going to mishandle the code. This is an example of tightly coupled code, and this is the communication between the songs list and the media player. In this code, the songs list needs to tell the media player to change the track. What it does is inside one of its methods, it is initializing a reference of its parent activity. Okay, and this activity is having a method that directly calls this activity has a method that triggers the change of track in media player. So the bad point here is the songs list fragment is dependent on the existence of music player activity. It cannot function without it. There is loose coupling. Loose coupling happens when components have very little, or in certain cases, virtually no idea about the other components involved, or at least not the significant components of the system of the communication channel. Significant, by significant I mean activities, fragments that you actually need to reuse at certain point of time. There could be other things which I'm considering here insignificant, like interfaces. Interface could easily be bundled with a fragment or an activity. That's quite common. So to decide upon good communication channel. Yeah.
Do you have an example of loose coupling?
Yeah. So we are going to have a lot of examples of loose coupling. The rest of talk is about loose coupling. So the goals of the basic goals for us by deciding on the communication channel are these three. Reduce the degree of dependency, that is decouple the code as much as possible. Keep the code efficient and keep it less painful for the developer. And then testing part is there is always conflicts between these 3 points, so you will have to settle down somewhere in the trade-off. First is interfaces. Interface is a very powerful component, and it is standard Java construct. So it is for that reason it is very efficient. And one benefit of using interfaces is that being it a standard Java component, a lot of developers, almost every developer knows about it. So it doesn't involve any extra learning curve. So your code's readability increases, and the efficiency obviously grows. But the one bad point of it is a lot of boilerplate code. I talk in detail about it.
This is like protocols for iOS, right?
Yeah. And like I talked about dependency. Dependency cannot be zeroed ever. So when you were doing type coupling, your dependency was on class or interface or multiple classes. When you involve interfaces, the dependency just switches from class level to interface level. Like if you are using an interface in place of class to do the communication between them, then instead of that significant class, our dependency is just switching to the interface.
So you're just adding an abstraction.
Yeah. Is it visible? Why should
That's true.
So this is a very simple example of interface. That we have an ATM machine. An ATM machine has a keypad, and the user comes to use the ATM machine. As long the user can make sense of the keypad and how to use it, he can do any transaction. He doesn't need to know about the bank. Suppose we didn't have the keypad. The user will have to go to an ATM machine. He needs to have deeper knowledge about the machine, how to interact with the machine. He needs to have internal knowledge about the machine. So the user is going to be tightly coupled with the machine. If user is going to use 5 different machines with different internal configurations, then the user is going to be tightly coupled with all those 5 machines. And with each new machine, he is going to have acquired knowledge of that particular machine and the internal configuration. But the interface, the keypad interface, is making it very easier for the user that he has got keys, and the internal implementation he doesn't need to know anything about. But still, the user is supposed to know about the keypad interface.
So the only one thing is if there are say multiple entities consuming this ATM machine, then all of these entities, so say one is user, one could be say customer, right? I'm just picking it up, right? So 2 entities, then both of them have to implement their own code base, because if you extend an interface, you have to do an implementation of your own. And so, I mean, don't you think it adds more code, or what you meant like a boilerplate code? It increases more volume of code.
It does. But it's the trade-off again that you at least get some decoupling of code.
So, I mean, where, for example, you are say constructing say web APIs. So in that case, you are promoting kind of a reusable code, so that multiple consumers or multiple entities can consume it.
Yeah.
So you can't expect those users to write their own implementation. You are just giving a skeleton.
So these are like callback methods which are called whenever some event happens. So when the music starts playing in this example, there is a interface method which is called that, okay, I did start playing this track, or I did stop playing this track, or so this object can implement play, pause, stop, forward, back, all of these methods, and then callback is called, which is being implemented by the interface. So interface is both the callbacks and the play, pause, stop methods.
But actually on the user side, it makes life easy. If you know this interface in 10 banks, it just extends.
No, of course,
and have the same interface. On the bank side, there might be an extra layer of work to subscribe to that interface and perform accordingly. But for the user, it becomes easy. You can go to any bank, the interface remains the same.
we consider it the other way around. The implementation of keypad interface has to be done by the ATM machine, not by the user. User can be anyone, just has to go to the go and interact with the keypad interface. The implementation of keypad is going to be implemented inside the machine. The user doesn't have to do it. So from our music player situation, I have one example of the interface, which is this particular communication. This one. The music player service needs to tell something about to the media player fragment. Yes. So we can create an interface for that. Interface is going to have two methods. One is on time of date, that's going to tell media player the log of the milliseconds. And the second one is track completion, on track complete. So the media player is going to implement implement this interface on time of date, and is going to update the progress bar inside it, and then the on track complete. Inside on track complete is going to further communicate it to the list, or it's going to change the track and it's going to notify everything that needs to know about that information. Once we have this interface in the media player, the music player activity can set this when media player implements this interface, media player activity, that is this activity which is containing media player and the list, would set this listener, set media player as the track listener of music player service. Now, whenever something related to this listener happens, media player service is going to notify it about it. But the point of worry is this point at this option is we just covered this communication from music player service to fragment, and we have this much of code. This is boilerplate. Then, if we follow this pattern everywhere, just for this communication from media player to media player service, we are going to have the same thing the other way around. So that's a lot of boilerplate. And this ultimately leads to the worst case called interface chaining. When this happens, when your communication nodes are having multiple layers between them. I'll give you an example. In this case, in this situation, I don't want this list fragments to interact directly with any other component in the system. I want list fragments to interact only via this list controller. This controller is actually encapsulating it, and list fragment could be of any type: songs list, albums list. The other components don't need to know about what kind of list is being displayed. So actually, this controller is an abstraction layer over it, and so the communication happens like this. List fragment tells any list fragment, song or album list. It first tells the list controller what it needs to do, and the communication is further pushed to the music player activity, and the music player activity tells the other components to do the further communication. So, in case media player needs to tell the song list to update the UI about a track change, the communication is going to happen like this. Media player will tell the player activity. Player activity is going to tell about this to list controller, and list controller is finally going to deliver the message to song list. So, in order to keep it decoupled and reusable, we would have to involve these three interfaces. So, interface chaining is actually a bad thing that personally pushed me to searching options to avoid this. So finally, the solution I found was message bus. This is a publisher-subscriber pattern of communication. Components can subscribe a message bus for a specific action or event, and publisher can post events on the bus, which will be distributed to all the subscribers that are listening on the message bus. This is the basic layout of how message bus works. This is the bus class. The bus class is basically an engine that keeps track of all the subscribers and publishers. Like maybe this activity could be a subscriber and this fragment could be a publisher. So whenever this fragment would post an event on message bus, this activity will get notified of it and it can act upon the data that event is providing it. We can have two different implementations of message bus. The first is implicit intent message bus. How many of you know about broadcast receivers in Android?
Not a lot of fun.
Okay. So broadcast receiver is quite similar to NS notifications and NS notification in iOS. So what you do is you define an action as a string and you broadcast it. Like I want to play a music with this track ID and you broadcast it. And all the components that are listening to this particular action is like play this music.
This particular event.
Yeah, this particular event is going to listen to it. Android has got a component called intent filters. Whenever this kind of request.
So is it like related to media type, or how do I register my intent to serve a request?
You can have a custom string. You can have.
No, my question is logical, not how you do the implementation. But like if I build my own media player, I'll register that if there is ever a broadcast that some media needs to be played, audio needs to be played, my app should also raise its hand.
Yeah, if you have a used Android phone, you get a chooser of different applications. If you start a map, you get a browser and Google Map option. That is how this is done. The chooser.
So both of them can actually satisfy this request, but
Yeah.
which one the user wants.
Yeah.
So
Yes,
both of
so-
them are registered for it, and whenever a call happens, the user selects which one.
Both the applications have put out their intent filters and
So in browsers, many years ago, now I haven't seen it recently, there used to be a thing called mime type. That was that if this is what the content is coming, then what are the browser components which can play that? So it's something similar.
Yeah.
It's still there.
But it's not that evident. Earlier it used to be like
exactly right.
every different kind of file you try to download, there'll be a pop-up with this mime type. What do you want to play it with?
Most of the 9 times are supported on browser like Chrome, OpenSPDF.
Right. Now they do it implicitly. Earlier they used to ask.
We can even give more detail about the data we want to involve in our task. Like if you have, even if you are playing a song, you want to play a song and you want to specify the format, you can do that. So the media players who entertain that particular format only would raise their hand. And the second type of message bus implementation is event-based message bus, which are implicit intent message bus based on broadcast receiver, like I told you. It serves as the highest degree of decoupling. Implicit intent bus most of the times just involves a single string to broadcast their message, broadcast whatever they want to notify other components. So dependency is just on a string that the communication patterns I have seen. That's the highest degree of decoupling. But the problem with it is the data has to be bundled, and bundling can be done only if the data is either parcelable or serializable. So that's an overhead. That if you want to custom data passed among between the components, the custom data, the custom class needs to be parcelable or serializable. So I'll show a simple example of implicit intent message bus. So this is a message bus based on broadcast receivers. All you have to do is you have to initialize the event bus inside your application, inside the application class, and in all the classes that are going to be included, that are going to be the nodes of the communication, you are going to register those classes, and the listener is actually going to be the class. You be writing this, the keyword this, and it is going to return your registration ID, which you are going to use while unregistering it. This is important. You need to register the class, and the ideal spots to do these two steps are on start and on stop lifecycle methods. So you see, the events. These are our events that we need to post on the bus, and the other components are either going to register these events if they are interested in these particular in whatever events they are interested in. They can register them, and whenever some other component posts this particular event on the message bus, those components or registered components are going to get notified of it. How posting of an event is done is like this. We define a bundle, we put all the data that we need in the event, and we send the event on the bus. We provide the event ID and the parameters that are going to be bundled along with the event, and this event is going to be received by all the registered classes. Registered classes are going to have this on event method. On event method will receive these parameters and they can act upon it whenever this particular event is posted on the bus. And these are the various options we have to in order to post an event. There's a term called sticky event that is quite interesting. I'll come back to it. So that is the same point. The data needs to be bundled in order to pass, and that is the most painful point. That is the most painful thing about implicit intent message bus, and a lot of developers are going to discard the uses of it just because of this point. So the other option we have is event bus. An event can be any Java class. Event can be posted on the bus, subscribed to and notified of identity couplets, similar or less boilerplate code, but not standard. As the concept of an event class is not standardized, a lot of developers are going to have trouble dealing with it, the nature, the working of it. And it's not efficient. I'm going to talk about the efficiency of it in upcoming slides. This is a sample event class, the download progress event. The download progress event has a parameter for progress, and it can be fetched and used by the listeners, most probably to update the UI. So event class could be this simple, or even simpler. We can have an event class without any parameter or methods inside it. Event bus actually can work in just these 4 steps. Define an event, register a subscriber, post an event, and receive the event and use it. Utilize it in whatever manner you want to. And these 4 steps have been, these are the 4 steps as used by Green Robots event bus. Define an event. This could be a minimal event. This is an event. This has nothing inside it. This class has nothing inside it. And then subscriber can register to event bus components can post events on it. Like it created an instance of this event and it posted it on the event bus. The registered subscribers are going to receive it inside a method, and they got the event if this event has got parameters and has got parameters inside it, they are going to utilize it for whatever update they need to do. So sticky events, as we saw in the fluffy events GitHub page, we could have few events, few particular events like location, last node location. So even if you had a location update in your location helper, location client class, and there is new component which is registering on the bus, it at least needs to know about the last location update. Like,
So usually, if it's not sticky, that event would be consumed and lost forever.
yeah, it will be lost.
But these would stay.
If you want to keep it put, so you need to make it a sticky event, and it will be retained by the event bus, and any new subscriber will get notified of it.
And it is retained till the next time the same event is triggered, or we can
All
specify.
the subscriber will get notified of this event again once again.
Only the last event. Only the last event.
Last.
Until the next one is generated. So till the next location is broadcasted, the last location would be broadcasted if a new subscriber comes.
Yeah.
Interesting.
So I have seen a lot of implementations of event bus, of which I found these two particularly interesting. First is Square's Photo. Square is a popular community. They give Android a lot of, they have given Android a lot of libraries even better than what Android gives as default. And recently their dependency injection library called Dagger has been made official by Android.
So this is the same Square that swipe card reader company.
Square, swipe card readers.
Square is a company which makes card readers for mobile smartphones. Should be the same. Those guys who commented on our blog post.
Yeah.
If these are the same Square, that is that story. They're the same. So they make smart card readers for smartphones.
So they have a minimal event bus library called Photo. Photo is actually extension of Guava's event bus. Guava is a generic core Java library, and they have an event bus that Square optimized for Android, and they called it Photo. And the other one is Green Rewards event bus. This is the best event bus I have found so far. I talk about both of them. First is Photo. So in order to use Photo, your application is going to have a bus. You can have a single bus, and or you can have multiple bus if you want to keep certain things separated. Okay, so rather than this, we mostly use a singleton pattern to keep a bus inside the application, and an event can be posted. Event is again a normal Java class. Event can be posted on the bus, and all the subscribers are going to get notified of it. Subscribers in the case of Photo are made just by doing this. Define a listener method. This is a listener method, and give it a notation of subscribe. That is subscribe, and whenever this class, the registering class is subscribed, it is loaded in the memory. Event bus, the auto event bus is going to iterate over its methods and check which all methods are having this subscribe annotation. It identifies it as a subscriber and it stores it in a map. And whenever related event, whenever this kind of event is posted in the message bus, the message bus is going to find what all methods have been registered for this particular event and they fire it. So, subscriber is going to register on bus. And this is how you can deal with threading inside the bus. There are two, Auto has provided two basic options for thread enforcement. One is main, that is you want your subscriber method to run only on the main thread, or any. The other option is of any, that if you want to, the subscriber method can run on whatever thread it was called. That depends upon what thread the message was posted, and this is going to happen synchronously. If you have multiple subscribers to an event, they will get triggered synchronously. And the other one is green rewards and rewards. Again, it's basically the same thing. The communication happens in the similar way. The publisher posts an event, and event bus checks what all subscribers have subscribed to this particular event and fires methods for them. The basic difference between Auto and event bus is Auto is annotation based and event bus is convention based. By that I mean this thing. In case of Auto, we were having this pattern that you provide a subscribe annotation with your subscriber method, and that's how a subscriber method is getting identified in the bus. But in case of green reward, we are having convention. A subscriber method is identified by the name of it. It's going to have the name on event and a single event inside it. The event bus engine is going to look for such methods with the name on event and an event inside it. That's the basic difference between Auto and green rewards event bus. But green rewards event bus is giving us much more options. So I will tell a little bit inside what happens inside a message bus, what happens behind the scene. So whenever class is loaded in memory, the event bus uses reflection to loop over all the methods of it, and it keeps track of all the subscriber methods and what events they are subscribed for. So, for example, this is a data structure in which it stores this mapping. Auto uses this data structure to store the mapping of events to their particular to all the methods that are inside the application. So this data structure is basically a map of class. This class is going to be any subscriber inside the application, and they are mapped to another map that is of an event class for type of event to the set of methods that are interested in listening to this particular event. So at certain point of time, if I have three classes loaded in the memory, so this map is going to have three keys for each of them, and a map of event to all their methods, to all the subscriber methods, and when one of these classes unregisters, its keys is dropped from this map. So at any instance, we are going to have a map of all the methods that are interested in events that are going to be posted on the bus. So when a publisher component publishes the post event on the message bus engine is going to iterate, is going to check in this particular data structure that if we have any method that is listening to that particular event, and whatever it finds, whatever method it finds is interested in this event, it calls that method for this class.
So this could be multiple methods also.
So there could be multiple methods
Because
for one particular event, and they are going to be called synchronously.
So the class that existed first is going to be notified first.
Yeah.
And then can it control whether I want to send it up above or stop it like
That is an option. That is an option Green Robot event bus is giving. You can set the priority of registration. So it ranges from 1 to 10, and you can give a point to give a point to each registration. That registration with
highest
maybe 10 is going to.
And the first two questions actually, and second was about bubbling. Can they control whether if I want to listen to this, then this doesn't need to go beyond it?
Yeah,
Like in government
not let it go out.
I think Green Report gives this option. Like if I have 10 listeners and they have different priorities, the listener with priority 8 doesn't want it to be carried out further. It can tell the event bus to stop distributing it further.
but can be risky. If we allow other apps to listen to them. But this is inter-app only.
Yeah, is intra-app.
Inter-app.
So this is how mapping is done. This map. I'm talking about this data structure, this mapping. This mapping is done in 2 steps. First, the loaded class. The methods of loaded class is looped over using reflection, and then for each method, either by looping over their annotations or looking into their conventions, we find the subscriber methods, and we store the information about the subscriber methods and the events they're interested in the data structure, in this data structure. So, can anyone tell me what performance posture I am talking about here? In these 2 steps, there is one thing that is going to hamper the performance a lot. Can you spot it?
Reflection.
Yeah. So, reflection is the monster here. Reflection is a highly processor-intensive task. Processor-intensive task.
Because it iterates over all the methods.
Yeah.
So it's costly.
And the worst thing about it is, if you suppose you have an activity, you have, one of your activities is a subscriber, and you need to loop over all these methods. It's not going to loop over your activity. The methods of your activity is going to go down to all the levels up to the object class. So in activity, in case of an activity, I saw it's around something around 270 methods is going to loop over, and in case of diamonds, it's something around 160.
So we should use reflection here when it's very much necessary.
Yeah.
Let's just try to avoid it.
We should try to avoid it, but it is a useful method. You don't have much options. I'm going to discuss that thing only. At the startup time, when your app starts, there are a lot of things that needs to be preloaded. Suppose you have a bitmap in your splash screen that needs some processing, some level of processing. That's going to consume your time. That's going to consume the startup time, and startup time is a rare resource. As in, like all the things that are going to consume will take a slice of your startup time. If they aggregate up to 300 or 400 milliseconds, that is going to be a sad thing for your application. The application will take 300 to 500 milliseconds to start up. That's a bad thing. So when you use reflection and you have your application doesn't involve any custom class, just go with the broadcast receiver based message bus. Otherwise, go for the event bus. Okay, that's it. Okay.
Thank you.